As usual, we have a problem that involves the manipulation of fractions. However, we find that this kind of a problem you will find more often than the other type on the examination paper. In number 1, we do not always have fractions to manipulate in this form, but we find that the problems involving fractions are the one that we have more often than not. Before going into the manipulation of the fractions, as usual, let us convert the mixed numbers to improper fractions. There we have labeled the different parts of the mixed number. We have the whole number, we have the numerator, and we have the denominator. In converting the mixed number to an improper fraction, first we multiply the denominator of the fraction by the whole number. That we will do first. So 4 multiplied by 1 is equal to 4. Then we proceed to add the numerator to the result. So 4 plus 3 is equal to 7. So 4 times 1 is 4, plus 3 is equal to 7, and that will be the numerator of the improper fraction. And of course, the denominator is the same as before. Do the same. Denominator, multiply that by the whole number. The result is 6. To that result of 6, we add the numerator, which is 1. 6 plus 1 is equal to 7. And that is the numerator of the improper fraction. And the denominator will be the same as the denominator that we had before. So let us go straight ahead. Rewriting the expression that we have, using the improper fractions that we obtained on the previous slide. So we have converted 1 3/4 to 7/4, and we have also converted 3½ to 7/2. Squaring a fraction is the same as squaring its numerator and squaring its denominator. So whereas we have 7/4 squared, to achieve the squaring of the fraction, we need to square the 7 and square the 4. In the meantime, what we have done is make use of the fact that dividing by any number for that matter is the same as multiplying by its reciprocal or multiplicative inverse. So we have, of course, squaring the 7 we get 49, squaring the 4 we get 16. Then we make use of the fact that dividing by a fraction or any number for that matter is actually multiplying by its reciprocal. So we have formed the reciprocal of 7/2, which is 2/7, and of course we have squared this fraction here. And we see common factors, so we will reduce the fraction by common factors. So the fraction may be reduced by a common factor of 7, then by a common factor of 2. We have 7 into 7 is 1, and 7 into 49 is 7. Of course, 2 into 2 is 1, and 2 into 16 is 8. So 7 into 7 is 1, 7 into 49 is 7. 2 into 16 is 8, and 2 into 2 is 1. 7 multiplied by 1 is 7, and multiply 8 by 1 we get 8. and that's all there is to it. Multiply the numbers as we have said before. 7 multiplied by 1 is 7, and we do that to the denominators also. Now we'll be working with decimals. Especially in recent years, the problems that require that we find the square root may be solved without the use of the calculator. We know that because there are 4 decimal places in the number, the square root will have 2 decimal places. So if we have a particular number, especially if the number of decimal places is even, say 6 decimal places, if we find the square root of that number, then the square root should have 3 decimal places. So while taking the square root of a number, we take half of the number of decimal places. Now we have 4 decimal places right there. Taking half of 4 is 2, so the answer should have 2 decimal places. Also, because 529 is close to 625, we may say that is not so close. Well, at least for a square, they are very close if we are talking about squares, because if we square 20, we get 400. If we square 21, we get 441. That one is, as a matter of fact, 41 units away. But because they are squares, we imagine that the greater the number that we square, then the further the numbers will be apart. Therefore, if we have 529 and 625, we think that those should be relatively close to each other, being square numbers, if we are saying that 529 is a square. So they should be very close. Now, since 625 is equal to 25 squared, then 529 could be, I'm not saying that it is, could be 23 squared. Because if the squares are close, we imagine that the numbers should be close, so we are just opting for 23. Now, focusing on the 9, 3 squared may also be a good clue. So if we are thinking about the 9 at the end, squaring 3 we get 9, although squaring a number that ends with a 7 also gives a number that ends with a 9. But we are saying that we are focusing on 23. So if it is actually the square of 23, then squaring 3 to give 9 will also be a good clue. So sometimes we could take an approach where we set aside the calculator and make use of our brain. Your calculator would have revealed that the square root of 0.0529 is in fact 0.23. I hope that no one attempted to add before finding the square root. Well, it is far-fetched that anyone would want to add this number to this one and then find the square root. We don't imagine that anyone will want to do that, but stranger things have happened. Now we will do the square root first, and then when we get the result, we add 0.216 to it. And we said that the square root of 0.0529, we could imagine without using the calculator that it is actually 0.23. But these days, CSEC examiners imagine that students have the calculators at their fingertips, so they expect that students will use them. So we have 0.23 plus 0.216, and that may be done in our minds without the use of a calculator. As a matter of fact, we realize that if we align the decimal places, although we're not doing that physically, but mentally we should be able to handle problems like these. If we align the decimal places, there will be no decimal place that is in line with the 6. It will go back, so we have a 6 there. So on the alignment of the decimal places, we realize that there is nothing that will be aligned with the 6. It will go right back, and we see that 1 plus 3 will be 4, and 2 plus 2 is 4, so 0.446, like that. It is required that the answer be finally written in standard form. There should be one non-zero digit to the left of the decimal point. By so doing, the number will be increased by 1 decimal place, or multiplied by 10. An adjustment will have to be made that will return the number to its initial value. We therefore divide by 10, which is equivalent to multiplying by 10 to the negative 1. So there we have it. Now we have this number 0.446. To write this in standard form requires that the decimal point will be here instead of here. By so doing, it means that we will be multiplying or increasing the number by 1 place of decimal. So we are increasing its value by 1 place of decimal, which is the same thing as multiplying by 10. Now we cannot just leave the number multiplied by 10. We have to bring it to its original value. So if we multiply by 10, to bring it back to its original value, we'll have to divide by 10. Dividing by 10 is the same as multiplying by 10 to the power of negative 1, and hence what we have right here. We may consider that making a small number larger will have to be compensated by making it small again. Therefore, any number that initially had 0 preceding the decimal point will be accompanied by a negative power of 10 in the end. The power of 10 will be determined by the number of decimal places by which it was increased. Therefore, if we have a small number, what we call a small number is a number with no non-zero digit preceding it. Therefore, any number that has 0 point something, we will consider that to be a small number. In the end, that number will have to be accompanied by a negative power of 10, because having 0 here means that we can only, by writing it in standard form, increase its value. Therefore, we will have to decrease its value again. So if we have no non-zero digit preceding the decimal point, we imagine that in the end we will have our number accompanied by a negative power of 10, and the power is determined by the number of decimal places that we increase the initial number by. Now we are given this problem in which the hourly rate of pay is $22.50, and we are talking about a 40 hours work week, and we need to find the weekly wage, and that will be done by, of course, multiplying the number of hours by how much is worked in a particular hour, and that is a simple result. $22.50 multiplied by 40 is equal to 900. As a matter of fact, 22 times 40 is equal to 880, and a half, so we have 0.5, which is a half. A half of 40 is 20, so we have 880 plus 20, and that will give us 900. So that is also something that we could have done mentally. 1.5 times the hourly rate may be taken at face value. We always associate times with multiplication. So for 1 hour of overtime, we multiply the hourly rate by 1.5. So we just need to determine the overtime rate, which is the overtime hourly rate, and it is 1.5 times. So multiply 1.5 times the hourly rate. So we have $22.50 multiplied by 1.5, which is 1.5, and this is the hourly rate, and this is the hourly rate for overtime work. We are told that the number of hours worked in a particular week is 52, and we need to know her wage for that particular week. What does that mean? If she is working 52 hours, that means she should be working a certain number of hours more than the regular working hours, because the regular working hours is 40 hours. Therefore, if she is working 52 hours, she is somewhat over that. Now we need to determine, because we just cannot go straight ahead and do all the calculations together, we have to consider that there's a particular rate, which is a different rate for regular hour as opposed to overtime hours. So we need to separate the regular time from the overtime, and we have 40 hours for regular time, so the overtime will be the difference between the regular hours and the total number of hours. 52 is the number of hours that she worked, and 40 is the number of regular hours. The difference between that will be the overtime hours. So 52 minus 40 is equal to 12. So that will be the number of hours that she worked overtime. The number of hours that we have calculated for the overtime will be multiplied by the overtime rate. And of course, we know that the regular wage for the week is what we have right here, is $900. So those $900 will represent all of the hours that she worked regularly, and then we'll add the overtime, which is 12 multiplied by the overtime rate. We'll add that to it. So there we have $900 plus 12 times the number of hours, that is 12 multiplied by the overtime rate, and that gives $1,305. In order to find the number of hours that she would need to work in order to earn $1,440, we need to subtract the regular weekly wage from that amount in order to determine the amount that she would earn in overtime wages. Then divide that amount by the hourly overtime rate. So we have 1,440. We will take away the regular wage from that, and then divide this value by the overtime rate and see what happens. So that turns out to be 16 hours. So we have 1,440, which is the amount of money that she needs to work. We subtract the regular salary, and with that result we divide by the overtime rate, and that turns out to be 16 hours. What we could have done also, we could have found the difference between this and the 1,440. Then we would divide that by $33.75, and after doing that, the result would turn out to be just 4 hours. Therefore, with the 12, the 4 hours will turn out to be 16 hours. So we could have taken that approach also.